All right, our final video for hypothesis tests. We're on page 10 of our notes. Today in class, you would be eating delicious Skittles. However, we're all stuck at home. So if you could get a bag of Skittles and you can try and run this on your own, that'd be super cool. Otherwise, stay at home, stay safe. And here's what we did. So many students claim they can taste different colors of Skittles. Today we'll conduct an experiment, perform significant tests, see if students can really taste the rainbow. So I went and pre-bought before the rush on Skittles, a bag of Skittles, and made my wife try and guess how many try to guess which color she was eating, and she got 38 correct out of 150. So we're going to do 4 steps here where we're going to start with stating our parameter. P is going to be the true proportion of our correct guesses. Our statistic, we got P hat is 38 out of 150. That's 0.253, and that 3 is repeating. We're given 5% hypothesis significance level here, and we're going to change out the next page to see. So you see it's not just all 5%, but it generally is 5% for the significance level. Our hypotheses, we got to think about a little bit. There's 5 different flavors of Skittles, so 1 out of 5 times you should guess it correctly, and that's going to be 0.2. So our null hypothesis is that if you're just actually guessing, you should get about 0.2, and we're going to see if my wife did better than that and got larger than 20%. We're going to do a 1 sample Z test for our proportion P. Check some conditions here, random. We randomly bought that bag of Skittles, 10%. That 150 Skittles is less than 1/10 or 10% of all Skittles. And our large counts, 150 times our 0.2 and 150 times 1 minus that 0.2, 0.8, those are both larger than or equal to 10. So we're good to go. Our formula to find our test statistic Z is going to be the statistic minus the null over the standard deviation. So P hat minus P, and then there's our standard deviation formula, which I actually plugged in the numbers and got to be approximately 0.0327. When I went and did my calculations for Z-score, I used 0.253333333 minus 0.20 over, and then I have this saved on my calculator, so I divided by that and got my Z-score to be 1.63. Our picture here with our mean and our new standard deviation, there's our mean of 0.2, and my wife ended up getting about 25 or a little more than 25% correct. Shaded to the right to see how often that would happen. Our Z-score is 1.63. So you should be thinking right now it's close to 2, but it's less than 2. So that should give you kind of an idea of what that will be. And when we actually go ahead and run this, you can do normal CDF like we've done before, or we can do a 1 prop Z test, and that's what I'm doing right now. I'm going to hit stat. I'm going to go over to test, and that's number 5. So I'll go stat over to test. Number 5 is my 1 prop Z test. I already have everything in here. 20%. She got 38 right out of 150, and we're going to see if she's better than the 20% or how often that would happen. And we get our Z-score there of 1.63. Good job. And look at our p-value there. Our p-value is 0.051. So we're trying to see if that is less than 0.05 or 5%, and it's actually just larger. So our conclusion is we do not have enough evidence, and we want to say we don't have enough evidence against the null hypothesis, since 0.051 is actually greater than 0.05. So we would say we would fail to reject the null hypothesis. Maybe if she'd gotten 1 or 2 more, we could say, hey, she can tell which colors are which. We got some notes for you here at the top of the next page, just those 4 steps. We're stating it. We want the parameter, the statistic, the hypothesis, and the confidence level alpha. Our plan, our name, and our conditions. I simplified the do down. I just want the picture, the work, and your answer for your Z-score. And our conclusion, we do or do not have enough evidence against the null, and because we're comparing 5%, this is a little over 5%, we did not have enough evidence against the null hypothesis. I do have a little note here for 2-sided tests. So we did a left-sided test earlier in our notes. Where was that? Way back on page 8, we did a left-tailed test. The test we just did just now is a right-tailed test. And we're actually going to see a two-sided test, two-tailed test here. We'll just multiply the p-value by 2. So we got a p-value of 0.05. We multiply that by 2 and get a little over 10%. That's what we compare to our significance level. So I want you to read through the check for your understanding. I just did the first part, the stating here for us. News report claims 75% of restaurant employees feel that work stress has a negative impact on their personal lives. Manager asked 100 employees, found that 68 said yes. When asked that question, does this data provide convincing evidence at the significance level of 10% that the proportion of all employees would say yes is differs from 0.75. So that word differs, it doesn't mean is larger than, is less than. It actually means is not equal to. So that two-sided tells us not equal to. So we'll have to keep this in mind when we are looking at our p-value there. The calculator might just give you the p-value. The calculator probably will just give you the correct value. So this is just using when you use table A, because you'll just get one side of table A and you'll have to multiply that by 2. The calculator should give you the correct value, and that's what I want you guys to practice this. So our parameter here is going to be the true proportion of employees who say yes, that work has a negative impact on your personal life. Our null hypothesis is that 75% are saying that would say yes. Our alternative hypothesis is that not 75% say that. Our statistic p-hat is going to be the 68 out of 100, 68% or 0.68, and we're looking at the significance level of 10% here. I want you to go ahead and try the rest of this on your own, even down here to number 2 as well. And when you're done, go ahead and check the answers that I've posted after this video. And then when you're good to go there, I want you to go try a short Math Excel for this week's assessment. Thanks so much. Talk to you next.